Gas flows easily, assumes the shape and volume of its container. Liquid assumes shape of what it occupies, not easily compressible. Solid retains fixed volume and shape, not easily compressible, very rigid. Center of atom, nucleus. Protons and neutrons are located inside the nucleus. Electrons orbit and rotate around the nucleus of an atom. Ions, positively and negatively charged atoms, do not have an equal number of protons and neutrons. Ions. Molecule, two or more atoms of same element, different elements bonded together. Diatomic, composed of two atoms. Molecules and compounds are different. Complex molecules are made of carbon bonded with other elements, especially OH and N. Physical properties. Measurable characteristics that describe the physical state of something, including mass, magnetism, temperature, density, shape, volume, and conductivity. Chemical properties. Characteristic that cannot be observed without altering the substance. Physical change. A change in a substance that does not involve a change in the identity of the substance. Chemical change. A change that occurs when one or more substances change into entirely new substances with different properties. Intensive properties do not depend on the amount of matter present. Extensive properties depend on the amount of matter present. Law of conservation of energy. The law that states that energy cannot be created or destroyed but can be changed from one form to another. Law of conservation of matter. Mass of the products has to equal the mass of the reactants. Kinetic energy. The energy an object has due to its motion. Any object in motion is using kinetic energy. Potential energy. Stored energy that results from the position or shape of an object. The energy that a ball has perched at the top of a hill is potential energy. Gravitational potential energy. Potential energy that depends on the height of an object. Elastic potential energy. The potential energy of an object that is stretched or compressed. Nuclear energy. The energy released during nuclear fission or fusion, especially when used to generate electricity. Chemical energy, stored in bonds of chemical substances. Electrical, form of energy resulting from the flow of an electrical charge. Energy is ability to do work or apply force to move an object. In the case of electrical energy, the force of the electrical attraction or repulsion between charged particles. Electromagnetic energy. Absorbed energy causes one or more electrons to change their location within the atom. When the electron returns to its original position, an electromagnetic wave is produced. Nuclear energy comes from splitting an atom in a reactor to heat water into steam. Nuclear technology and power is obtained by nuclear fission, nuclear decay, and nuclear fusion. Thermal energy comes from heat. Heat is generated by movement of tiny particles within an object. The faster particles move, the more blank energy is built. Thermal. First law of thermodynamics. Energy can be transferred and transformed, but it cannot be created or destroyed. Second law of thermodynamics. When energy is changed from one form to another, some useful energy is always degraded into lower quality energy. Thermodynamic temperature, Kelvin. Third law of thermodynamics. No system can reach absolute zero. Heat transfer formula. Q equals mCAT. Q equals amount of energy transferred. M equals amount of substance in kilograms. C equals specific heat of a substance. AT equals change in temp. Heat capacity. The amount of heat needed to increase the temperature of an object exactly 1 degree Celsius. Specific heat capacity formula. Q equals mCT. Recombination. process of positive ions of a plasma capture a free electron and combine with electrons or negative ions to form neutral atoms. Ionization. Energetic electrons interact with solid or gas phase atoms or molecules to produce ions. Vaporization. Conversion of a substance from a liquid or solid into the gas phase. Condensation. Substance in gas state transforming into liquid state. Deposition. Gas transforms into solid without passing to liquid. Sublimation. Transition from solid to gas without liquid phase. Freezing. Liquid to solid. Melting. Solid to liquid. Heat of fusion. Molecules within the substance becomes less organized. Solid turning to liquid water with change on enthalpy is positive. Calculating heat of sublimation. Dividing heat absorbed by the substance/mass of substance in grams. Energy equals enthalpy. Ideal gas law. Collision or impact between particles are elastic. Real gas behavior. Agrees with ideal gas equation. Endothermic, involving absorption of heat. Exothermic, releases heat. Bond energy bond enthalpy. Measure of bond strength in a chemical bond. Hess's law. The overall enthalpy change in a reaction is equal to the sum of enthalpy changes for the individual steps in the process. First law of thermodynamics. Energy cannot be created or destroyed. Second law of thermodynamics. Every energy transfer or transformation increases the entropy of the universe. Third law of thermodynamics. Absolute zero cannot be reached. Absolute zero. Lowest temperature theoretically possible. Entropy. Thermodynamic property that is a measure of a system's thermal energy per unit of temperature. Spontaneous process. Occurs naturally under certain conditions. Non-spontaneous process. DOESNT take place unless driven by a continual input of energies. Reversible process. Direction can be reversed by inducing changes to a property in the system via surroundings. Changes in enthalpy. Change in potential energy of the system. Exchange in enthalpy that results from a chemical reaction is the enthalpy of the reaction. Entropy. Measure of thermal energy per unit temperature unavailable for doing useful work. Change in enthalpy measured by delta H. If you are calculating entropy change, you must multiply the change value by 1000. Gibbs energy combines enthalpy and entropy into a single value. Delta G is equal to the sum of the enthalpy plus product of the temperature and entropy of the system. Subatomic particles. Particles smaller than an atom or cluster of particles. Orbitals. Regions around the nucleus in which given electron or electron pair is likely to be found. Quantum number. Size of orbital showing distance of the electron from the nucleus. Cathode ray tube. Vacuum tube that contains one or more electron guns and the phosphorescent screen used to display images. Who came up with the cathode ray tube? Carl Ferdinand Braun in 1897. Who came up with the gold foil experiment? Ernest Rutherford 1908. What is a gold foil experiment? Discovered that every atom contains a nucleus where its positive charge. Spectral lines. Dark or bright lines in a uniform and continuous spectrum resulting from emission or absorption of light in a narrow frequency range. Isotopes. Variants of particular element which differ in neutron number. All isotopes of a given element have the same number of protons but different numbers of neutrons in each atom. Mass number. The total number of protons and neutrons in the nucleus of an atom. Atomic mass. Sum of masses of its isotopes, each multiplied by its natural abundance. Aufbau principle. ground state of an atom or ion, electrons fill atomic orbitals of the lowest available energy levels. Hund's rule. Every orbital in a sublevel is singly occupied before any orbital is doubly occupied. Pauli exclusion principle. No two electrons in the same atom can have the same set of 4 quantum numbers. As an orbital can contain maximum of only 2 electrons, the 2 electrons must have opposing spins. Electron configuration. The distribution of electrons of an atom or molecule in atomic or molecular orbitals. Arrangement of electrons is responsible for the shape of the periodic table. Electron configurations can be predicted by the position of an atom on a periodic table. There is a relationship between the electron configuration of an element and its resulting chemical-physical properties. Other elements need to lose or gain electrons to obtain an octet. Alpha particle. A cluster of 2 protons and 2 neutrons emitted from a nucleus in one type of radioactivity. Beta particle. A high-speed electron with one charge that is emitted during radioactive decay. Gamma particle. A form of radiation. It's a type of electromagnetic radiation at a high frequency. Radiation. Subdivision of nuclear chemistry, which is the study of the chemical effects of radiation on matter. Radioactive decay. Process by which an unstable atomic nucleus loses energy by emitting radiation like alpha, beta, and gamma ray or electrons. Half-life. Length of time required for half of the radioactive atoms in a sample to decay. Fission. The action of dividing or splitting something into 2 or more parts. Fusion. Creation of energy by joining the nuclei of 2 hydrogen atoms to form helium. 4 types of nuclear reactions: fission, fusion, nuclear decay, and transmutation. What is transmutation? Action of changing or state of being changed into another form. Ground state. Atomic nucleus, atom, or molecule is its lowest energy state. Higher energy states are described as excited state. Excited state atoms are atoms which the total energy of the electrons can be lowered by transferring 1 or more electrons to different orbitals. Absorption spectra. A spectrum of electromagnetic radiation transmitted through a substance showing dark lines or bands due to absorption of specific wavelengths. Emission spectra. Heating a gas which electrons in the atoms absorb the heat energy, allowing them to jump into higher energy levels. The greater the energy, the larger the frequency and shorter the wavelength. The higher the frequency, the shorter the wavelength. Binary compounds. Compounds composed of 2 elements. Acids. H-containing substances that have pH less than 7. Base. A substance that decreases the hydrogen ion concentration in its solution. Soluble bases are called alkalis. Alkalis have a telephone greater than 7. Neutralization is a reaction between an acid and an alkali that forms a salt and a water. Salts are odorless and have a salty taste and soluble in water. Indicators. Substances that change color when exposed to acid or base solutions. Alkanes. Organic compounds made entirely of carbon-carbon and carbon-hydrogen single bonds. Alkanes. Hydrocarbons with 1 or more carbon-carbon double bonds. Alkyne, triple bond. Alcohol. Organic compounds that contain an ether group, oxygen connected to 2 alkyl or aryl groups. Follow general formula ROR. Ketones. Organic compound with structure of carboxyl group. Aldehydes. Carbonyl group bonded to 2 hydrogen atoms. Carbonyl group, bonded to 1 hydrogen and 1 carbon group. Aldehyde represented as CHO. Amines. Organic compounds which contain and often based on one or more atoms of nitrogen. One or more of the hydrogen atoms from ammonia are replaced by organic substituents like alkyl and aryl groups. Avogadro's number. Number of representative particles in a mole, 6.02 x 10 to the 23. Empirical formula. A chemical formula showing the ratio of elements in a compound rather than the total number of atoms. Molecular formula. A chemical formula that shows the number and kinds of atoms in a molecule, but not the arrangement of the atoms. Molecular formulas tell you how many atoms of each element are in a compound, while empirical formulas tell you the simplest and most reduced ratio of elements in a compound. Formula for mass percent. Mass total mass x 100. Longer the atom is involved in a bond, the longer the bond length. More bonds means shorter bond length. What is the strongest bond length? Triple bond. What is ionic bonding? Ionic bonding is bonds that have electrostatic attraction. When oppositely charged ions form an ionic bond, you get an ionic compound. Covalent bonding results from the sharing of electron pairs between two atoms. Nonpolar bond. Two atoms share a pair of electrons with each other. Hybridization. Mixing of atomic orbitals into new hybrid orbital with different energies and shapes. Metallic bonding. Type of chemical bonding that rises from the electrostatic attractive force between conduction electrons. Valence electrons. S and p orbitals of the interactive metal atoms delocalize. When multiple Lewis structures can represent the same compound, the different Lewis formulas are called resonance structure. Delocalization. Compare two or more Lewis structures that can represent a particular model. Molecular geometry. The arrangement of atoms determined by the arrangement of bonding electron pairs and lone pairs around the central atom in a molecule. Identifying polar and nonpolar molecules. Complete Lewis structures to determine shape. What is an easy way of showing covalent bonding in organic molecules? Structures and structural formulas. Symmetric shapes. Linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral, square, planar. Unsymmetric shapes, bend, trigonal, pyramidal. Hydrogen bonding. The intermolecular force in which a hydrogen atom that is bonded to a highly electronegative atom is attracted to an unshared pair of electrons of an electronegative atom in a nearby molecule. London forces. The weak attractive forces between molecules resulting from the small, instantaneous dipoles that occur because of the varying positions of the electrons during their motion about nuclei. Dipole-dipole forces. Attractions between oppositely charged regions of polar molecules. Weakest to strongest bonds. London dipole H ion. Intermolecular forces. Forces of attraction between molecules. Intramolecular forces. Forces within molecules. Forces caused by the attraction and repulsion of charged particles. Boiling point. The temperature at which a liquid changes to a gas. Melting point. The temperature at which a solid becomes a liquid. Melting point is the same as freezing point. What is solubility? The ability of a solute to dissolve in a solvent. Equilibrium vapor pressure. The pressure exerted by a vapor in equilibrium with its corresponding liquid at a given temperature. Metals, good conductors of heat and electric current. Nonmetals, elements that are poor conductors of heat and electric current. Metallite, an element that has properties of both metals and nonmetals. Transition metal, one of the elements in groups 3 through 12 of the periodic table. Atomic radius. Half the diameter of a neutral atom and measures across the outer stable electrons. Ionic radius, half the distance between two ions that are barely touching each other. Ionization energy, minimum amount of energy required to remove the loosely bound electron of an isolated neutral gas atom or molecule. Ionization energy is measured in kilojoule per mole. Outermost electrons have the lowest energies than inner shell electrons. Electron affinity. The change in energy of a neutral atom when an electron is added to the atom to form a negative ion. Electronegativity, a measure of the tendency of an atom to attract a bonding pair of electrons. Conductivity. The degree to which a specified material conducts electricity calculated as a ratio of the current density in the material to the electric field that causes the flow of current. It is the reciprocal of the resistivity. Chemical reactivity, tendency of a substance to undergo chemical changes in its system. Non-metal tends to attract additional valence electrons to attain a full valence shell. Simple chemical equations. Number of atoms of each type of atom must be the same on each side of the equation. Oxidation reduction reaction. Any chemical change in which one species is oxidized and another species is reduced, also called redox reaction. Stoichiometric. Calculation of the quantities of reactants and products in a chemical reaction. The quantitative relationship between reactants and products in a chemical reaction. Steps to calculate stoichiometry. Balance equations. Convert units of substance to moles. Use mole ratio to calculate the moles of substance yielded by the reaction and convert moles of wanted substance to desired units. Combustion reaction. A chemical reaction that occurs when a substance reacts with oxygen, releasing energy in the form of heat and light. Combustion reaction is almost always exothermic. When organic molecules combust, the reaction products are carbon dioxide and water as well as heat.